but I want to temporarily veer away from Chapter 3 to show the creation of a structure, data structure, that you can use to hold multiple pieces of data. Because what we've been doing so far is just like holding one piece of data and then another kind of sequentially, right? Instead, you can create what's known as a structure in order to hold multiple pieces of data, and the data can be related to each other. Like you might create a structure called point, which holds an x coordinate and a y coordinate. Or you might create a structure called block, which holds a height, width, and a depth value. So just so that we start getting familiar with doing that, not that we're going to do a lot with it right now, I do want to demo it. I believe we're on Lecture H.
Professor, before we get too deep into this,
Yeah, sure.
I got a question about the last one.
Oh, yeah, sure.
You said it do on.
So this would be a perfectly good example of using a struct. Right? Because we've got several pieces of data we care about, right? The P, the rate, the N, and the years. However, since that's 4 variables, I'm going to go in and make a structure that contains just 2 variables. Like a fraction, which has a numerator and a denominator, which I will just call top and bottom, because it's more fun to type top and bottom than numerator and denominator. So let me grab my boilerplate so I can copy it into a new file. Alrighty. So fractions got 2 things in it. I'm going to use the struct keyword, and I'm putting it outside of main. Now technically I could put it inside of main, but then other functions in the same file would not be able to get a hold of it, because the same rules for local variables would apply for definitions like this. If I define structure inside main, then any other functions in there wouldn't be able to use it. So struct, and I need to give it a good name. I'm going to call it fraction. And then I need an open curly brace, a closed curly brace, and a semicolon. If you've done Java programming, this is extraordinarily similar to how you define a class, except in Java you don't use that semicolon there. Okay, so what does a fraction got? It's got a numerator and a denominator, and usually those are whole numbers. So I'm just going to make this a whole number. Int top, semicolon, and int bottom, semicolon. And down here I'm going to make some fraction objects. How about 2 of them? Fraction f1, comma f2. f1.top equals 10, semicolon, f1.bottom equals 20. So that's 10 over 20. Now it'd be kind of neat if we had some routine that would go and simplify the fraction, right, to be 1/2. We're not taking this example nearly that far. And then f2.top equals 1, semicolon, and f2.bottom equals 3, semicolon. Right, so we've created 2 fractions. Now we have 2 separate objects, each carting around their own data, grouped together, right? That all applies to fraction 1. This all applies to fraction 2. Like you could have a book object, and the book would contain a book title and an author's name and a publication date and a company and the number of pages and whether you have any in stock, right? All that kind of information. The price, right? That's pretty important if you're doing some kind of book inventory for a store. All that information would be part of the book structure. Now, in this particular language, you would probably make this a class rather than a structure. Structures were introduced with C in 1970. Class was introduced. It got class in the 80s. It got classy. But there's a difference. If I make this say class, it will no longer compile because these variables are now private, meaning that we can't get a hold of them. I can't access them like that. So to keep the example as simple as possible for right now, I'm going to leave this as a struct. The idea behind a class is that a class is a structure with functions attached to it. And then those functions are called methods. I wonder why it's underlining that as an error. If I Control S to save it, is it going to remove that error? Yes, it did. Okay. So what's so great about that? Well, let's write a function that will accept a fraction and print out the result, right? 1 over divide the top by the bottom. So void space, or let's actually return the value so that we could print it out, right? So double space fraction underscore value parentheses fraction space f end parentheses. And so we need to divide the top by the bottom and return it. However, since these are integers, it's not just as easy as doing this. This would give us the wrong answer. If I did return f dot top divided by f dot bottom, what is the problem? The problem is, as I believe we have mentioned, it will do integer division. Both of these are integers. It's going to divide the top by the bottom and then round down. In both cases, that would result in 0. So I need to convert these. I need to cast them to be doubles. So I'm going to say double parentheses f dot top in parentheses divided by double parentheses f dot bottom in parentheses. Now we're good to go, right? So we could print out the value of each fraction.
Quick question.
Yes, sir.
So we were talking about what was it called? Apparens? Or anyways, my question is that since we're doing the casting, can you just cast one of them?
Exactly. This was overkill. I did not need to cast them both because to prevent integer division, only one of them needed to be an int. The reason I did both of them, and I'm really glad you caught me on that, called me out on it, is because if I'd written this, especially if I had written the other syntax for casting, which is to do this, somebody might think that it was taking the entire result and casting it, right? Since I did it with the double function, right, like the Python style conversion, it didn't look like that. But in Java, you don't have that style of conversion. You only have this style. And so I tend to put it on both sides just so that people don't think that it's doing this math first and then converting it. But it's absolutely true. You only need to convert one of the values to get it to force it to do floating point math rather than integer math. So I could leave it like that. Well, let's print out our fractions now. Go down here to the bottom. Cout less than fraction underscore value parentheses f1 in parentheses less than endl, and then I'm just going to copy and paste that and change the f1 to f2. So why would you care? Because it's a lot better to have your data clustered together by their meaning. Like if you're tracking data about, substances, it's a lot better to have one object that indicates or can contain the object's density, its mass, its volume, its name, whatever you needed to know about it. Or, if it's some kind of furniture or whatever, that one object can contain, what kind of wood the furniture is made out of, its price, whether it's used or new, all that kind of information can be bundled together, passed around as a single parameter. See, I was able to pass it around as a single parameter here. when you have a structure, you can initialize the values as you create it. I could have created it like this. Fraction F3 parentheses, and this fraction is 2 comma 5. It's 2 over 5. And is it going to give me an error about this? Okay, never mind. I was wrong. Delete that. I could go and modify the fraction class so that would work, but I'm not going to. If I wanted to, I'm calling it a class again. If I wanted to, I could put this function inside the class itself, or a version of it, right? And then I would be able to ask the fraction itself to give me its value. But we'll save that for another day. And be good to get back to. Anybody have syntax errors they would like help vanishing? Conquering. By the way, the quizzes have been posted. The due date for quiz 3 has been set for a week from today, which is a little bit optimistic since we're not done with chapter 3 yet, so I'm going to extend it. But I made quiz 2 do a week from today because we're already well past chapter 2 being done. All right, so back to overflow. We did examples of overflow. It's just when your data exceeds the number of bits that are available to hold it. Once the data gets above 2 billion for an int, you know, or whatever the maximum size for that data type is, then you're going to get data overflow. And underflow is if it gets to a negative version, right, that's too small. Typecasting. 3 different types of casting, and this is actually the preferred type. And when I say preferred, it's the way that C++ developers, the inventors of the language, suggest you do it, and there are good reasons for it, but the syntax is so much longer, and the purposes to which we are using casting is so simple that I haven't been teaching to it pretty much. But there are 3 ways of casting, and this is one of them. If I skip a couple of slides, it'll probably show, nope, it only really shows only that one. I swear it would show multiple. Then maybe I should abandon the other way. So if I was going to modify my code to use this static cast, it would look like this. I would take that word double and instead make my expression look like this. Static underscore cast less than double greater than, open parentheses, variable, close parentheses. So why would you want to use static cast rather than a normal cast? Older style cast. Well, that's when you Google up why use static cast and you go and read up at Stack Overflow or whatever. Why use static cast? Objection, Your Honor, asked and answered. Every time you go to Stack Overflow, you'll see somebody complain the question has already been asked. Yeah, so I'm not going to get into it. And then there's another form called dynamic cast. Dynamic cast is useful when you don't know what the dynamic type of the object is. Returns a null pointer if it can't be converted. Well, we don't care about that yet. All right, so casting. Casting is when you take data of one format and you convert it to another. Here we're taking this integer and we're converting it to a double so that we can do this division correctly on it. And as I mentioned, there are other 3 formats of them. Int x equals int parentheses d, if d was a double or whatever you needed to convert to an int, that's one format. Int x equals parentheses int end parentheses d. And then there's that static cast syntax. Int x equals static underscore cast less than d, no, less than int greater than parentheses d in parentheses. You can see why I usually type one of these instead. These 2 do exactly the same thing. And I know that there's a difference between the 2, and I'm not going to look it up and remind myself in order to tell you. Here we go. C style and pre-standard typecasts. This is the C style, the kind that was invented in the 70s when the original C language was invented. And then when C++ was invented, they threw it in a different way that matches the Python syntax. They're both still supported, but static cast is preferred. Notice how vague they are about why. They don't even get into it. Multiple assignment and combined assignment. If you feel like it, you can assign multiple variables at the same time. X equals Y equals Z equals 5. And that's because the assignment operator has right to left associativity. Starts at the right and then starts copying it to the left. So this is the first thing that happens. 5 gets copied into Z, and then the result of that, which is 5, gets copied into Y, and then the result of that gets copied into X. Can't say I use that an awful lot, but if you declare 7 different variables and you want to set them all equal to 0, that's a faster way of doing it than saying, you know, A1 equals 0, A2 equals 0, A3 equals 0, and so on. Combined assignment is when you do, instead of that, you do sum plus equals 1, like that. You're assigning it and doing a math operation at the same time. Python supports this syntax. I know I'm always referring to Python, but I know that 3/4 of the class just took Python last semester, and so it's fresh in your brains. So this is the same thing as that. And if you want to do multiplication, then you would put an asterisk there. If you want to do division, you put a slash there. If you want to do modulus, you put a modulus there, and so on. There's a special form of the assignment, combined assignment, called the increment, where you just do sum plus plus. And that means take sum and add 1 to it. All 3 of these statements do the exact same thing. If I had a preference, if I had to pick one, I would do the bottom one. You can kind of see, you know, even where the language got its name, right? C++, it means it's one better than the C language. So this is the increment operator. And if you use minus minus, that's the decrement operator. There is no star star, you know, or divide divide. It doesn't make any sense. What would you be multiplying it by? So x equals x plus 4, sure. X equals x minus 3, we could rewrite them. X plus equals 4. Go back. X minus equals 3. X times equals 10. X divide equals 2. You just have to get the order of the parameters correct. If you're going to say x equals x plus 1 and you want to rewrite that with the combined, then you would not say x equals minus 1 or x equals plus 1. Because what's that going to do? It's just going to copy 1 into x, right? Instead, you say x plus equals 1. The actual arithmetic operator has to come before the equal sign to get it to work. And like I said, that's the 3rd version. All 3 do the same thing. This is also known as a compound assignment operator. Compound because it does 2 different things. It does a math calculation and then it stores it back into itself. Math and then reassign. Formatting output. This is kind of tedious. Why do I say it's kind of tedious? It's a lot harder than it is in Java and in Python and stuff like that. In those languages, you had the ability to display your data with a statement like this. You want to format something to 2 decimal places, you could do this. I'm going to do the Java form of it. %.2f, end quote, percent, you know, and then the number I wanted to print, 3.14159. That would print it out to 2 decimal places. Maybe you remember seeing that. Java works the same way, except they call it printf. They actually stole printf from the original C language, and we could use that, but that's not what the chapter is going to show us. Let's see if we can actually get that to work, though. So, double space value equals fraction underscore value parentheses f1 in parentheses semicolon. I think I've goofed that. That's because that was supposed to be an underscore there. Tell you what, that's too much. How about just making it a 3.14159? And now let's print it out old school C fashion Same way that you would do in Python or in Java. Ooh, it doesn't even like the word print. It's printf, quote, %.toF, meaning floating point, end quote, comma, value. That's one way of formatting your data. Printf doesn't go to the next line automatically, so I would then want to do either a cout like that, or I could just put a \n right here, and it would go out to the next line. And since I have 0.2, it's only going to display 2 digits after the decimal point. And there we go. So that's why we got 3.14. I'm feeling like using printf a lot just because a lot of people still use it, even though C++ has the IO stream. Why would you not want to use printf? Because IO stream, which is what these are, work with not just screen output. You could send data to a file or to a socket to go down the internet. It's a lot more flexible in purpose than printf is. So if you want to format your data the same way using IO stream, it's a lot more trouble. Let me show you what you're going to have to do. You would do this: cout less than, fixed less than, set precision, or actually I just think it's precision. And I have not included the correct include file, so I'm not actually getting any indication or help as I type it. The include file you need is called iomanip, M-A-N-I-P. So #include less than, iomanip greater than. This lets me do formatted output. So if you're typing in the examples, I know not everybody is, but if you are, you better add iomanip up to the top. Well, I'm not getting the helper at all that I'm expecting, so I'm just going to actually look at the PowerPoint to show me how to do it. So you can control the size of the output. Like if you're printing a number, you can say, well, I actually want you to fill in 10 spaces on the screen. And why do you care? Because you might want your numbers to line up. You might want them to line up cleanly in columns. Or their position, whether they're left justified or right justified, and the number of digits after the decimal place. So to do that, it requires the iomanip. setW indicates how wide. It'll pad it out with spaces in order to fill that much space. Why would you want to do that? Okay, let's make some output that looks really lousy because it's not padded. So since this was failing anyways, I'm going to get rid of that and I'm going to write a loop that'll do what I want. Int x equals 1 semicolon while parentheses x less than 30 cout less than x less than quote space quote less than POW x to the power of 2 or x to the power of 4, just so that these numbers get really large really quickly. So now when I run it, I'm going to see that the output's not real pretty. Well, for one thing, I wrote an infinite loop. That was not my goal. X++. I needed to add that. You got to update your counter if you have a while statement based on that counter. Right, and there it goes. And they're not lined up. It's not too cool. In this particular case, this first piece of data, it'd be nice if it occupied 2 spaces rather than 1 up here and then 2 down here. And that's what setW does. I can modify my code so that before I print out x, I call setW parentheses 2 or 3 or 4 or 5, however many spaces I want it to occupy. And then less than x. Now I'm actually going to hit enter at that point because I want it to be real blatant what's going on there. If I wanted to set the width of this one as well, I'd have to call set W again. Well, how wide does that one get? I'd have to go back and look at my output to see. Looks like it gets up to 1, 2, 3, 4, 5, 6 digits. Might be worth formatting that one with a set W as well. So before POW, I need to do less than set W parentheses 6 in parentheses. Less than POW, like that, right? And yeah, I'm making the print statement occupy a whole bunch of different lines, but that's because I want it to be absolutely clear that set W only refers to the very next thing that's being printed. Once I set this thing to a width of 2 and it's done, nothing else is set to 2. So then when I wanted to reformat this one, I had to call set W again. Now that I have, the output's going to be nicely lined up in columns. Like that, right? Much better. That's what you use I/O manipulators for. It's one of the uses. What about picking the number of decimal places you want to print? You have these calculations, and it printed out, decided that 1 over 3 was 0.333, you know, out to 6 places, or 9 or 18 or whatever, and you really only wanted one decimal place, one place after the decimal. You can use I/O manipulators to do that. So let's do that. Let's kind of copy this idea here. But let's write it as a for loop just for the practice of for loops. I don't even recall if we've seriously covered them, but there's nothing wrong with seeing them. For loops are kind of like a keystone of the language. Int I equals 1, semicolon, i's less than or equal to 10, semicolon, I plus plus. Now these are semicolons separating the parts of the for statement. And then after the end parentheses, I'm going to calculate a ratio, 1 over I. And I need to store it in a double so it won't just be rounded down. So double inverse equals, or reciprocal, isn't that what it's called, is equal to 1.0 divided by I. 1.0 in order to ensure it doesn't do integer math. And now let's print out I'm tempted just to grab all this, copy it, and paste it and make some changes. I'm going to do that. Right? Because we're at a good start at printing things in columns. It's just not perfect yet. So why not? I'm going to copy all that stuff, paste it here. But the first thing we're printing is not X. We don't have an X, right? So I'm going to put an I there. You saw what I did. I just copied and pasted, and the first piece of data after the set W2 is an I, and the next thing we're printing, instead of POW X comma 4, is just the value of the reciprocal variable, inverse. So it's going to print out 1 over 1, 1 over 2, 1 over 3, all the way down to 1 over 10. Right. Oh boy. Looks lame. How wide would we need this to be for it to look a little bit better? Well, it's got 1, 2, 3, 4, 5, 6, 7, 8 places, including the decimal point. So a quick fix to making it look better might be to do this. Change that set W6 to set W8. That's going to make it look a little bit better. And I'll pause and walk about just a sec. So there we go. See? A little bit better, but what if I wanted all of them to have the same number of decimal places, like 1.00, right? Or 0.50, or 0.33. Well, we can do that. We can do that as well. Set precision and fixed. And show point, which always prints a decimal place. So we're going to send fixed and set precision and show point to the IO stream. And we're going to use set precision to 2, which means 2 places after the decimal point. So here, you don't need to do it every time, unlike set W. Set W you have to use every single time you want to change. These are kind of like fire and forget. You set it once and it'll remain fixed until you change it. So cout less than, fixed less than, what was the second one besides show precision? Show point. I don't even think that's necessary, but I'm putting it in there. And then less than, set precision parentheses 2 in parentheses. This sets up the IO stream so that every floating point number that comes down the pike is going to have 2 digits after the decimal point. And so it does, right? So 1 over 1 is 1, 1 over 2 is 0.5, 1 over 3 is 0.33, 1 over 4 is 0.25. Now maybe 2 decimal points isn't enough for me. Maybe I feel like making them 4. So I'm going to come up here and make it set precision 4 rather than 2. There. I like that output. I'm happy with it. So those are what the modifiers do. You include IO manip in order to use them. Once you've used IO manip, you have several that you want to use, several that you can use. You can use set W, which sets the number of spaces it will get padded out to. It's how many columns wide that number is supposed to occupy. Or string, if it's not a number, you can still use set W in front of it. And then you have fixed, and this would have worked just fine without show point. So I'm going to get rid of show point, not even mention it. What does fixed do? Fixed forces it to use decimal notation for floating point values. So even if it was tempted to switch showing to exponential, fixed causes it to stick to decimal. This forces decimal output of float values or double values. And then set precision sets the number of places after the decimal point. If you do not use fixed, set precision does something entirely different. If you've taken physics or chemistry, you're used to the idea of the precision of a number. And if you have a precision of 6, it just means it has 6 digits total. And then a certain number of zeros can follow it, but it's still only got 6 digits of precision. And so if you say set precision X without fixed, it changes the way it behaves to do it in that physics chemistry fashion. I'm not going to bother explaining that because I kind of botched it right there. For the most part, we like it like this. We like our numbers to line up like this. Notice that this is right justified, right? If you want it left justified, there's yet another IO manipulator you can use that'll line them up on the left margin rather than the right. These are the biggies as far as I'm concerned. Well, I mean, I guess it's important. Let's go and get that one as well. Set W, fixed, show point, set precision, left and right. Right, so if you want to right justify it rather than left, you can do that. Just use that word. So let's write some code that'll print out a little bit of a table. It's going to look like a multiplication table where we have numbers going across the top and numbers going down the side. And then in the middle of it is going to be a grid of multiplied values, like 1 times 1, 1 times 2, 1 times 3, and so forth. That's going to require what's known as a nested loop. Just kind of trust in the force. If you haven't seen for loops before in any language, just trust that this is going to work. Int x equals 1, semicolon, x less than or equal to 9, semicolon, or how about going all the way out to 10, just for giggles. X less than or equal to 10, semicolon, x plus plus, That's what's known as the outer loop. We're going to embed another loop inside it for int y equals 1, semicolon, y less than or equal to 10, semicolon, y plus plus. And we're going to see out less than x times y less than, and not ENDL. I mean, I could do ENDL, but look what its output's going to look like. It's not going to look like a multiplication table at all. Right? Not cool. So, I don't want to use the ENDL there. I want it to do after it's printed out an entire row of numbers. Then hit enter. Just like we were typing the numbers in. So that ENDL needs to be after the inner loop. See out less than ENDL. Okay, now I forgot to put a space. That's a real lame multiplication table, right? But I could also use a set W to handle it, right? If I put a set W in front of this, it would set the width. I was actually planning on making this a homework assignment, but it's so easy that I'm just going to go ahead and do this. Set W, parentheses, 4 ought to be enough, right? Because we're going up to 100. And I need a less than in front of that. And there we go. There's our cute little math table. 10 times 10 is 100. Working with characters and string objects. CIN with greater than can cause problems because it stops when it hits a space. What do I mean by that? If I ask for their name and I want them to type in their first and their last name, it's going to stop after their first name. Watch this. See out less than, quote, please enter first and last name, colon, space, end quote, semicolon. Now let's declare a string to hold our results. String name. And then CIN greater than in the name. And then let's print out the name. See out less than hello, comma, end quote, less than name, less than ENDL. So when it runs, what's it going to print? Well, if I type in two things, it's only going to print one thing. Please enter your first and last name. Okay, my name is Donald Trump. And it says, hello, Donald. Well, that's good, right? But I really wanted it to print the whole name. That was my goal. And then let's say that we wanted to ask one more question, like what city they lived in. So see out less than, what city do you live in? End quote, semicolon, string city, CIN greater than city, semicolon. And so not only are we going to print hello, we're going to say see out less than, how is the weather in, end quote, less than city, less than ENDL. Looks like good code. Looks like it ought to work perfectly. It's not going to work perfectly. Please enter first and last name. Okay, Joe Bob. What city do you live in? It didn't even let me type an answer in. And then it said, hello, Joe. How is the weather in Bob? Not what I wanted. What's it doing? It's taking all of my input and dividing it up by the spaces. So the only thing that got stored in name is Joe. And then it took that Bob and it put it into city. And then the rest of the input, too bad. It never even got to it. So if you need them to enter data that has a space in it, one or more spaces, you can't really do it that way. Okay, well, why didn't we just ask them to enter the first name and then the last name as two separate pieces of data? Well, you know, some people only have one name, right? You know, Cher and Bono and, you know. all those people with only one name. They may not want to enter 2 names, or they may want to enter 3 names, right? Even though you only ask for first and last name, they type in a middle initial. It's going to mess it up. So instead, we need a command that'll read in the entire line at one get-go, rather than just one piece, right? This only gets the first, what's called as tokenized. Tokenized means that it goes until the space or the carriage return, right? Splits it up into tokens, and we only get a little piece of it. So instead, we're going to do it like this. Get line. We're going to use a function that gets the entire line worth of data.
So a quick question.
Yeah.
If you don't have a second input, and they put 2 values in for their first input, what happens to that second value?
It's just lost.
Does it store it in memory and it just stays there? Like it takes up
Well,
space?
once the program's done, then it's flushed. It's gone forever. Until your program is done running, then yeah, it's hanging out in memory waiting to be read. That's called the input buffer. Everything you type in is stored in a buffer, and then each call to arrow just pulls in the next little chunk of data from the input buffer. It's a very good question. And so that's why when I typed in Joe Bob, the first little bit went into name, and then the rest of it was left in the buffer, and so Bob went into the city. Now you can clear the input buffer between calls to CIN less than, and so at the very least, we would have gotten Joe here and then the first word of the city, which wouldn't have helped, right? If it was New York, then it would have said city equals new. Would have left off York. So instead we're going to use get line. Get line parentheses, CIN, comma, and then the variable you're filling in. The syntax looks a little bit different. So instead of that, I'm going to use get line parentheses, CIN, comma, name. That gets an entire line's worth of data, not just the first tokenized piece. Same for CIN less than city. Since it might have 1 or more spaces in it, I suppose there could be cities with 5 different spaces in their name. Get line parentheses, CIN, comma, city in parentheses. Now when it runs, it'll print out our data appropriately. Enter your first last name, Joe Bob, I live in New Amsterdam. And it says, hello, Joe Bob, how's the weather in New Amsterdam? So it actually worked. You only need to use get line if the data you're trying to come in, if your data you're trying to pull in has potential spaces in it. It doesn't demand that it has spaces in it. It'll work just as well if it doesn't. Like if I type this, Joe, no problem, it'll still work, and I live in Tulsa. It worked just as well because it read to the end of the line. I want to kind of loop back to your question. What if we did this? CIN or Cout less than enter X. And I don't remember if we have an X and a Y variable set. Yeah, it kind of looks like we do. Or how about, okay, enter A, int A, CIN into A, and then Cout less than, enter B, int B, CIN greater than, into B, and then print out Cout A plus B, less than ENDL. If I type in 2 pieces of data when it was only expecting 1, Joe, Tulsa, enter A, and I type in 2 pieces of data, 1 and 10, the B hangs out in memory and then immediately goes into B. I didn't even get a chance to type in B. And then it printed the result 11. And it just looks kind of weird, but that's the way that CIN works. Is if you give it too much data, the data is left in memory to fill in the next variable that it asks for. There's a way of clearing the buffer so that that doesn't happen. And you could clear the buffer between every call to CIN if you were paranoid about somebody having typed in more data than you were expecting. Also, what if you want just to get a single character? You create a variable called CH. You tell them strike any key to continue. And then so you do CIN greater than CH. Well, that doesn't work. They have to strike a key and then hit the enter key, the return button, for it to work. Well, that's two keys. And if they just hit the enter key, it won't even work. You get hit enter 100 times. You've already seen that happen before. Right. Finally, I give up and I type in a number. It won't work. So there's another call that'll get a single character. If you feel like it, you can use that. CIN.get parentheses CH. It'll get the next key that is pressed, even if it's a space. So this program is paused. Press enter to continue. CIN.get parentheses CH. This would be the ideal replacement for that system pause at the end, which is specific to Windows. Doesn't work on Mac, doesn't work on Linux, so it's a non-standard thing that we're doing down at the bottom of our code to keep the window open. We could replace it with this. Let's give that a shot. I'm going to remove this system pause, declare a character, char ch. I'm going to tell them to press enter, so cout lesson, press enter, end quote, semicolon, and then I'm going to do CIN.get CH. I saw something interesting. Why was I calling get line parentheses CIN when that function exists? Well, I don't know. I'm not going to figure it out. Just following the book. That's how you would do it. I believe. I think I botched the syntax. Let's go and look. Oh, excuse me. It's just .get. So CIN.get parentheses variable name. Yeah, once you get to the point where it's asking for so much input, it gets kind of tedious. Well, it didn't work, and I was fully expecting it not to work. CIN.get is a funny little beast. It's like it'll pick up the last carriage return that was hit, like it's treating it as though that is left in memory, even if it's really not. And so to get CIN.get ch to work, you need to clear the buffer before you call it, or else it better be the first thing in the program. Which is why their little example here works perfectly, because CIN.get is the first thing in the program, so that no inner keys that have been buffered ready for it to pull in. Now I keep mentioning clearing the buffer. Here's how you can do it. You call .ignore. CIN.ignore will clear the buffer. You can specify how many characters you want to clear, or until a new line. Let's see if we can fix it using like this statement here. CIN.ignore that. I'm going to stick that up front of this. CIN.ignore up to 10 characters. Well, what if they typed in more than 10 characters? I could type in CIN.ignore 9999, right, just to be paranoid. Anyways, I'll go with their book's example, \n. Now let's see if that works. Now maybe you can see why I've just been using system pause rather than do those 4 statements. And sure, I could put those 4 statements into my into my boilerplate, but meh. All right, fine. Now it's working correctly. It's waiting actually for me to hit enter. So you could do that. You could use these 4 statements, or you could use system pause. Now you can't use system pause if you're not using Windows, and so if you really wanted to put a break, a pause into your code, you might want to do that. If I was going to do that, here's what I would do instead. I would take that code and I would put it as part of a function, like void pause, like that. And that way, anytime I wanted to pause, I could just call pause. pause 10 times in a row, I could, right? That way I don't have to type this business every single time. If you feel like being awesome and switching over to using this, go for it. If I notice you doing it, I might even give you an extra credit point. Which, when you're getting 10 points per program, is 10% extra credit. It's pretty cool. But I have to notice it. Anytime you do something that you're hoping to get extra credit for, you might put it in as a text comment while you're uploading it, just to flag it, make absolutely sure I catch it. I certainly don't mind you asking for the extra credit. Alright, so that's what cin.ignore does. Wipes out what's ever in the keyboard buffer so that the statement after that has a better chance of working. String functions. This chapter just goes all over the place. We just jump from one topic to another. To find the length of a string, you call .length. Rather than in Python, you call it len parentheses string name. In this one, you use string name.length. It's the same one you'd see in Java. To concatenate, to join multiple strings, you use a plus sign. So if we did this, string first, wait, we already had first. No, we just had name. String first equals Joe. String last equals Bob. And then we wanted to set Joe equal, excuse me, if we wanted to reset our name variable, name equals first plus last, that's not good enough, because when it's done, it's going to say Joe Bob. So I would want to concat one more thing into it, which is a space. First plus quote space quote plus last. Now it'll say Joe Bob. And if I print it out, I would see that. And if I care about the length of it, which in certain applications you might, like what if you had a whole bunch of names to print? If you could determine the length of the longest name, then you could use set W followed by that value in order to make sure that all the names occupy the same space on the screen. It would require a loop. It would require all that data to be stored in an array or some other structure. Anyways, we could do name.length, parentheses in parentheses, ENDL. And so it's going to print Joe Bob, and it's going to print out 7. As soon as I enter all this data yet again. There we go. Right. Joe Bob 7. So use plus to concatenate strings, which just means append one to another. You can also use plus equals. Like if I do string equals H, and then I do S plus equals A. After that, string now equals HA. Use s.length to get the length of string. Come on. Same as len parentheses s, Python. More math library functions. If you bring in CMath, you get sine, cosine, tangent, square root, log, abs, and POW. Although Microsoft being non-standard gives you POW anyways, you don't strictly need to bring in CMath in order to get it. But on other, not everybody's doing it with the Windows compiler. So I don't much care about sine and cosine and tangent. Square root's really useful. ABS is really useful. So if I wanted us to print out the square root of a series of numbers, then I would use a square root function. If I wanted to use the ABS in order to get the absolute magnitude of something, just drops the minus sign, I could do that. If you're going to compare floating point values, you want to use the absolute value of the difference between that value and your target value to determine whether it's small enough or not, whether the error is small enough to be an acceptable value. So, CMath has cool functions like POW, ABS, SQRT. Those are like the most common. Also sine, cosine, tangent. It's got a whole bunch of them. Tell you what, let's do this. Double D equals the square root of 99. And then let's see if we can go to where square root is originally defined. There's a way you can right-click on something and ask it to tell you where it was defined. For example, I have a name variable I've been using off and on. If I come up here and I highlight name and I right-click and say go to definition, it shows me where it was first defined. How about that pause function? I called pause somewhere here, around here. Of course I can't spot it now. There it is. If I highlight that, right-click and do peek definition, gives me a preview of where it was defined. That's useful. Or if I right-click and do go to definition, shows me that. Useful stuff. How about if I take the square root function and find out where it is declared? So go to definition of it. And oh boy. Alrighty, I'm not smart enough to understand all this. One thing it's doing though, no, that's beyond me to explain that at all. They're going to a lot of work using something called templates in order to make it so that the square root function will work with doubles and long longs and floats and doubles and long doubles and shorts and everything. So we're seeing templates used in order to accomplish that, and that syntax can be pretty involved, as we can see here. But I did want to point out that you can go and find a declaration of anything, except if it's a keyword. I can't right-click on int and say go to the definition. It's a keyword. Anything else I ought to be able to do that. Show me the definition of cout. Cool. Again, it's a bit above my pay grade to understand that, but I can look at it. When you're writing your own code, it's very useful to be able to go and see where something is declared, especially when things are declared in multiple files. You have 10 files that are working together. You're using a variable in one that was defined in another. More math. CSTDLIB. Now we've gotten to something really fun, which is a random function. Use random to create games, for example, like dice rolling games, right? To represent a die. You like Dungeons and Dragons or Pathfinder, you might need to roll a number between 1 and 20. And you'd use a random function to do that. Or you're doing Yahtzee, you'd want to be able to generate numbers between 1 and 6. So rand returns a number between 0 and the largest int that the computer can hold, which is about 2 billion. Now honestly, I think that it's inaccurate, but it does return a number between 0 and a fairly large number. And we're going to demonstrate this, and this will probably be the last thing that we do with it. So I'm going to come up here and include the CSTDLIB, because that's necessary for this, for the rand function, CSTDLIB. And I'm going to be making y'all use the random number function in homework, just not today. That's the rand function. And so down in main, I'm going to use it. Like maybe I'll just print out 10 random numbers in a row. And I'm going to put it at the top so I don't have to keep entering Donald Trump's name. So for parentheses int I equals 0, semicolon I less than 10, because I wanted to print out 10 numbers, I plus plus, or I could have gotten 1 to less than or equal to 10, right? But you get that. Now let's get a random number. Int x, int r for random equals RAND, parentheses in parentheses, and let's print it out. Cout less than, quote, random equals, end quote, less than r less than ENDL. So we should see 10 pieces of data come out. And then I'm going to pause. And there they go. Cool deal. I have 10 numbers. Now, that's a pretty big die, right? That's a die with 24,000 sides on it. And I don't want that. What if I just want to generate a number between 1 and 10? I can use modulus for that. Or if I want it to be between 1 and 6. What I do is I take the result, I modulus it by 6, and I add 1 to it, and that gives me a number between 1 and 6. There we go, right? Now, something you will notice, this is true in this language, that doesn't happen in Java and Python, is that the same sequence is returned every time. Do I like my dice program to always roll the numbers in the same sequence every time? Probably not. So there's another function you have to use that's called a seed function, srand. So before the first time I call rand, I need to do srand and give it a so-called seed. So why am I having to do that? Because these are not really truly random numbers. There's no possible way, well, I won't say no possible way, but how could a computer calculate a purely random number? Everything that a computer does is based on formulas, right? So whatever formula it's going to use, it's got to start somewhere. And so the random number generator, what it does is it uses the last random number that it generated in order to make the next one. And it does it through a formula complicated enough that we can't predict its results. If we can't predict its results, it looks random to us. But it always starts with the same number. And so this next number is based on the last number, and the next number is based on the last one, so it's a predictable series. We see the same series every time. So we want to give it a different starting value, and that's what srand does. So what if I seed it with the number 1, 2, 3? That'll work.
So you're telling me that those dice apps are lying to us?
They're not truly random. That's correct. I mean, about the only way you could generate a random number would be if you could use some kind of Geiger counter to click the number to count the number of gamma rays a second that was hitting it, or something like that, some physical basis, or who knows, maybe quantum computers could do it. But it can be faked. How do you fake it? I mean, now that I've set the seed for it, it's generating a different sequence, but still the same sequence every time. The way you get around that is you seed it with a clock value, like the number of seconds since midnight. It's very unlikely that I'm going to run it at the same time every day in order to notice that it's going to generate the same series. So what people usually do is they call a time function to get a number, and then they use that to fill that in. And I hope this gives us an example of that. It'll be the last thing we do today. No, of course not. Yeah. All right. So Google that up. It's always okay to Google. It's just not okay to go and take, 10, 20 lines, copy and paste. So time srand C++. Here we go. We're going to need yet another boilerplate, ctime, in order to get the time function. My boilerplate has just increased by 3 lines, hasn't it? So # include ctime, and I'm going to get a time value to use as my seed right here. So time parentheses 0, and that's going to introduce us some kind of warning that I could do some casting or something like that to get rid of, and I'm not going to bother. But anyways, okay, now it's going to generate a different series each and every time. So now it's actually doing some fun. But there may be times when you actually want it to generate the same sequence every time, right? What if you're fine-tuning some algorithm and it's important for you to figure out why halfway through it failed? Well, then you might want it to generate the same sequence every time, in which case you might want to hard-code your seed to a specific value, and then then and only then, when your program is all debugged, then you go and replace it with time 0. So I did give y'all homework on Tuesday, I hope, right? Yeah, I did. So I don't have to give you another one today if I'm following the 1 a week thing that I've been doing for a little while. All right. But random numbers are kind of fun. People get the idea of dice, right? Like you roll 2 dice. What's the most commonly rolled number when you roll 2 dice together? 7, right? What's the least commonly rolled number when you're rolling 2 dice? Either 2 or 12. Why? Because there's more ways to add up to 7 than there are 2 and 12. There's only one way to add up to a 12, and that's with if you get a 6 and a 6. But you can add up to a 7 with a 1 and a 6, or a 2 and a 4, or 3, whatever. I'm messing that up, but you get the idea. We could print out a graph showing the relative probability of 2 dice and what number that they roll. It would look something like this. Histogram, 2 dice. Like that. So 7 is definitely rolled more often than 2 or 12, just because more numbers add up to 7. This shows all the different combinations, right? Only one combination rolls up to a 2, only one combination rolls up to a 12, but a lot of different ones add up to 7. So we'll do some stuff with random numbers, so we're going to hit that topic again. I think this is far enough now, and I think that I'm happy with the homework assignment we've already got for the week, so let's stop.